Assalamualaikum dan selamat sejahtera. My name is Nurhamizah binti Anuar. Today I would like to present the introduction, objective and scopes of this study. This project is about designing 3 different mold designs for clothespin that will analyze which is the best design among them. In design stage, 3 mold concepts have been prepared via SolidWorks software. The simulation of injection molding was conducted by using Autodesk Mold Flow software. The factors that considered for parameter in design are runner system and getting system. The objective is to design 3 mold for a clothespin by using SolidWorks software version 2016. And the second one is to perform injection molding simulation for the 3 mold design by using Autodesk Mold Flow 2019 software. And the scopes of this study is the size and dimension for clothespin was same. The types of runner was round and trapezoidal. The material for the mold design are same. The type of gate for each mold design are different. And the design using SolidWorks 2016 and simulation using Autodesk Mold Flow. The product based on the specification for NESE NP7 1F machine.
Hi and Assalamualaikum. My name is Athirah binti Ahmad. I would like to present the literature review in this study. Firstly, the literature review has been made from the topic of pipe thickness. The Journal of Pipe Thickness was written by Roger T. in 2014. In this journal, he said that thickness of the pipe is important to minimize the defect such as warpage and twist or cracks. Next, he also said that pipe thickness will affect the cost, strength, and production speed. The thicker pipe will cost more, but it will give more strength to the product. Next topic is injection mold design. It was written by John E. Haley in 2009. He said that in injection molding, mold design is important for productivity and sellability of the product. The important parts that will affect the productivity including screw bushing, runners and gates, hot manifold, venting, cooling and injection. And lastly, the literature review has been made for the topic injection molding process. It was written by Malloy in 1994. Malloy said that injection molding process was used injection molding machine to produce plastic parts or products.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wardiah Afiqah binti Muhamad Wazir, and I will explain about our methodology. So first we start with initial design. We design 3 sketch design and review the specification for mold design. We choose 1 out of 3 design that's suitable with specification for mold design in this project. And then from the design, we sketch roughly layout design, feed system, cooling system and ejector system with full dimension. After that, the design were created by using SolidWorks software. This is because to ensure that it could run the analysis perfectly. Next, insert all the materials that we use on this project in SolidWorks software. The next step is the mold design analysis by using Autodesk Mold Flow. This software used to analyze mold design together with the simulation for injection molding process. After run the simulation, result for the analysis will show. If there is no any error during the simulation, it means the project was successful and project will be closed. If not, the process needs to be repeated from step of design all the system using SolidWorks and proceed until get good result. Lastly, close the project. That's all. Thank you.
So next is the design parameter. We are using 4 types of parameter: runner, gate, ejector and cooling system. We also using 3 design which is design 1, design 2 and design 3. For runner, at design 1, we are using cool runner, full round shape, 5 mm diameter and 3 mm diameter, 35 mm, 16.5 mm and 12 mm in length. For design 2, we are using cold runner, full round shape, 5 mm and 3 mm in diameter, 50 mm, 19.5 mm and 9.5 mm in length. And for design 3, we are using cold runner with trapezoidal shape, 6.35 mm by 5.825 mm and 4 mm by 3.65 mm of cross-sectional, 50 mm, 18 mm and 5 mm in length. Next, we're moving to the gate. So for design 1, we are using H gate, thickness at 1.5 mm, width 2 mm, length 3.5 by 2.5 mm. And for design 2, we are using fan gate with thickness 2 mm, width 5.21 by 3 and 4.161 by 3 mm. Length 4.64 by 3.25 mm and 4.03 by 2.84 mm. And for design 3, we are using H gate, thickness 1.5 mm, width 2 mm, length 4.04 by 3.5 and 3.48 by 2.94 mm. Next, the parameter are ejector and cooling system. For design 1, ejector pin are used 5 pin, 6 mm in diameter and have uniform ejector force. And for design 2, we are using pin ejector size 10 mm and 0.15 mm away from edge of cavity. The pin ejector is less expensive. It's the reason we are choosing it. And for design 3, pin ejector, 7 ejector that are 5 mm away from edge of cavity. Dimension of size are 8.5 mm. Ejector pin provide one of the cheapest form of ejector available are the reason for design 3. And next is the cooling system. For design 1, we are using normal cooling with baffle channel. Design 2, normal cooling with baffle channel. But baffle channel because baffle will make the mold cool faster. And for design 3, we are using normal cooling with baffle channel. And because of the same reason, baffle will make the mold cool faster.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Afiqah binti Abdul Wahid. So today I will explain about the result of the simulation that we have been made from the SolidWorks design. So table 3 is the comparison of data of design 1, design 2 and design 3. So we can see that the design 2 give the best cycle time, which is 78.33 seconds compared to design 1 and design 3. So we can see that design 2 have the time when it completely fill, which is 0.6261. The temperature when filled is 221.0. The injection pressure is 9.255. The pressure drop is also 9.255. And the time reach ejection temperature is 96.38, which is give the lowest value. So we can conclude that the design 2 has the best value from the design 1 and design 3.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad Ariffuddin bin Ibrahim, and I will explain about the discussion of projects. So in our project, we found out that design 2 has the best cycle time. So why? Why do the design 2 has the best cycle time? So as shown in the picture, we can see that design 1 has 96.12 second cycle time and design 2 has 78.33 second cycle time. And for design 3, we have 87.92 second cycle time. So for the cycle time, the shorter it is, the better the result. So in this case, we take the design 2 cycle time, which is 78.22 seconds, as the best type of mold. So moving on, design 2 parameter results in the best mold. So which parameter do we refer to in this case? So in this case, we refer to the type of runner and the type of gate. So in design 1, we can see that the distance between the two runner is nearer to each other. And for design 2, we can see that the runner is farther from each other, same as design 3. So the difference between the design 2 and design 3 is the type of runner. So in design 2, we use full round runner. For design 3, we use trapezoidal runner. So for the type of gate, in design 1, we use H gate. In design 2, we use fan gate as shown in the picture. And for design 3, we use H gate. So we also found out that the fan gate produced the best result for the cycle time and for the cycle time. So design 2 has the best mold in our project. That's all for me. Thank you.
As for conclusion, from the analysis, the difference of the design product gives the different parts quality. There are 4 parts quality can be considered in this project, which are the runner, gate, ejector, and the cooling system. According to the simulation analysis, the chosen design for fabrication of mold is design 2, which has the best cycle time because it is the shortest time. As for recommendation, maybe in future can use the different type of gate or runner as well as to optimize the parameter setting based on the different factors and levels, or fabricate the real mold and carry out the real practical injection mold process with the same parameter setting for comparison of findings. That's all from us. Thank you.